Welcome to this Masterclass Explainer. Today, we're doing something absolutely crucial, bridging that massive gap between deep technical infrastructure and top-tier enterprise business value. We are talking about architecting secure AI pipelines. Now, if you've spent any time in the trenches of enterprise IT like I have, you know that deploying a model in a cute little sandbox is one thing, but securing it in a live, high-stakes production environment, think peak-hour banking, well, that's an entirely different beast, isn't it? We're going to map out exactly how to build, secure, and maintain these pipelines, and do it without sacrificing an ounce of system stability.
To give us some methodical clarity, here's our architectural blueprint for today. We'll cover the modern DBA evolution, production realities, data stewardship, secure AI pipelines, model serving security, and finally, the strategic IT architect. Let's dive right in.
Section 1. The modern DBA evolution, shifting to AI architects.
Okay, let's talk about the macro shift that is completely rewiring the 2026 tech landscape. The traditional role of the database administrator, it is fundamentally transforming. Look at this staggering number. According to the Robert Half 2026 Demand for Skilled Talent report, job postings for AI, machine learning, and data science roles spiked by literally 163% in just 1 year. That's nearly 50,000 postings. This isn't just a passing trend, folks. It's an absolute mandate. The industry is desperately seeking pros who can not only manage data, but actually design the infrastructure that feeds all this automation and predictive insight. For those of us who are existing DBAs, the urgency to evolve into AI architects has never been clearer. And honestly, here is exactly why organizations are struggling to execute on this. Look at the Q1 2026 unemployment rates for critical infrastructure roles. They are virtually non-existent. Network and systems administrators are sitting at a mere 0.4% unemployment. Think about that. That means the only way to hire one right now is to poach one from someone else. The talent pool is completely drained. When you can't just go out and hire external talent to build and deploy AI, the competitive advantage your business is banking on just completely stalls out. The bottom line? Existing technical leaders have to step up, bridge the gap, and master AI architecture from within.
Which brings us to Section 2. Realities of production environments, what I like to call the IT battlefield.
Let's step on to that IT battlefield for a minute. Lock contention, replication lag, disaster recovery drills, these are the daily fires we fight, right? And right now, AI initiatives are the ones most impacted by skills shortages and these system complexities. This brings us to a massive business value proposition. The reactive cycle, waiting for failures to occur and then scrambling to fix them, is a recipe for maximum disruption. It basically treats IT as a massive cost center. But contrast that with predictive monitoring. By using AI algorithms to analyze system logs and detect anomalies, like, say, disk failures or unusual login attempts, before they actually cause downtime, you completely transform IT into a production enabler. You literally prevent outages during those critical peak business hours. The cost savings and operational stability gained here are just absolutely immense.
Now, before we start looking under the hood at specific tools and scripts, we need to understand the structural roadmap. This right here is the MLSecOps, or Machine Learning Security Operations, lifecycle. It requires 4 methodical steps. Step 1, data engineering. Step 2, pipeline development and testing. Step 3, continuous integration, delivery, and training. And finally, Step 4, model serving. We are going to construct this layer by layer together so you don't get lost in the weeds. Sound good?
All right, Section 3. Layer 1, data stewardship.
Listen, secure AI starts long before a single model is ever trained. It starts right at the foundation. Responsible data quality isn't just operational housekeeping. Honestly, it's a matter of professional ethics. We are talking about lineage transparency, strict metadata quality, and continuous monitoring right from the point of ingestion, treating every single database like a highly critical, protected asset. Organizations absolutely must treat data quality as a shared accountability. So we deploy open-source tools like Great Expectations here to enforce business rules and detect anomalies. Think of it as your very first line of defense against poison data sneaking into your pipelines.
So the absolutely crucial point here is establishing what we call model provenance. Provenance is all about maintaining a completely transparent, version-controlled lineage of your datasets and models. Utilizing tools like DVC, data version control, allows you to trace exactly where a dataset came from and, more importantly, roll it back if any tampering is detected. Because without provenance, reproducing a model's results or defending against adversarial data injection is, well, it's effectively impossible.
Moving right along to Section 4, Layer 2, Secure AI pipelines.
And this brilliantly illustrates the next jump. We've secured the data, now we must secure the actual mechanics of how that data trains our models. You see, in traditional software, you deploy your code and it generally stays static, right? But in AI, we use continuous training, or CT. This means we are regularly retraining our machine learning model by feeding it new, live data through an automated loop. But here is the harsh reality of production environments. Frequent retraining introduces massive vulnerability vectors. Think about it. If an attacker poisons that incoming data stream, your automated pipeline is going to diligently train a compromised, malicious model and push it straight into production. No way we can let that happen.
To mitigate these kinds of supply chain attacks across the pipeline, we map specific open-source tools to our MLSecOps stages. We already mentioned DVC for data engineering. In the CI/CD and continuous training stages, we rely heavily on a tool called SigStore for cryptographic model signing. That ensures our artifacts are totally tamper-proof. We also use OpenSSF Scorecard to constantly evaluate the security posture of our third-party dependencies. And finally, as we move toward model serving, we look to tools like Selden Core for orchestration and Garrick for vulnerability scanning.
Which leads us perfectly into Section 5, Layer 3, Model Serving Security.
Now, what's really interesting about this slide is that this is inference. This is where your model actually goes live and interacts with real client requests. Securing this pipeline requires a very strict defense in-depth approach. We're talking access control, output filtering, and continuous adversarial monitoring. You use SigStore to verify the model hasn't been altered right before it executes. You use Garrick to actively evaluate vulnerabilities like prompt injection. And you deploy tools like Evidently to monitor data drift and performance degradation in real time. If that live model starts behaving erratically, these are the tools that trigger the alerts and prevent a catastrophic business impact.
But, even with absolutely perfect pipelines, we still face a profound challenge, particularly if you're working in highly regulated environments like banking and finance. So how do we manage the opacity of complex AI models in production? Deep learning models are essentially black boxes, right? Their internal logic just isn't human-readable. If an adversarial backdoor is subtly embedded within the model's weights, standard security scans simply won't find it. So what does this all mean for us?
Well, the solution to this opacity risk is evaluating models inside a trusted execution environment, or TEE for short. Now, a TEE doesn't magically make a deep learning model fully transparent, I wish it did, but it does allow you to test the model against a secure dataset in a completely isolated, tamper-proof enclave. It then generates an attestation. Think of it like a cryptographically guaranteed scorecard that proves the model performed exactly as expected without any human interference or data leakage. Only models bearing this strict, tamper-proof attestation are allowed to pass that threshold into production.
And finally, Section 6, the Strategic IT Architect. We have completely traversed the technical roadmap today, from raw data ingestion all the way to secure production serving. Now, let's bring this full circle back to you. I want to leave you with this final thought. AI automates routine technical tasks, raising the importance of human judgment, ethical decision-making, and communication. You see, the ultimate safeguard in a highly automated AI-driven enterprise isn't just a fancy new software tool. It's your strategic oversight, your ability to interpret AI outputs, to govern ethical deployment, and to ensure rock-solid system stability. That is your ultimate differentiator. So, as AI takes over the routine, the real question is, are you ready to step up and architect the future?